Okay, so this is the lesson on solubility, and I'm going to want to draw on this one. Okay, so recall that a solution is a homogeneous mixture where the different substances are mixed evenly throughout so that you can't distinguish between the different substances. Okay, an example of a solution would be fresh lemonade, which is a mixture of water, lemon juice, and sugar. Now, while you can dissolve a lot of sugar in water, there is actually a limit where no more sugar will dissolve, and the sugar will just sit at the bottom, and the solution won't taste any sweeter. You may have seen that when you've put too much sugar in your coffee or in hot tea, and the sugar just sits at the bottom. Okay, so what solubility means? Solubility refers to the maximum amount of a solute that can be dissolved in a given amount of solvent at a constant temperature. Right, so temperature is involved here. As you heat a substance, as you heat a solvent, more solute can generally be dissolved. All right, so solubility is usually measured by how much solute can be dissolved in 100 grams of water at 20 degrees Celsius. Right, the 20 degrees Celsius is key because that's room temperature. The 100 grams of water is key because a good thing about the metric system and about water is that 100 grams of water equals to 100 milliliters of water. Okay. All right, and so if we look here, we've got table salt, right, and that's 36 grams of table salt can be dissolved in 100 grams of water at room temperature. Baking soda, 9.6 grams, and sugar, 203.9 grams of sugar. Okay, and so what this is telling us is that sugar is a lot more soluble than table salt is. And both are a lot more soluble than baking soda is in water at room temperature. Okay, so we would say that sugar has a higher solubility than salt or baking soda. All right, as temperature increases, as I mentioned before, more solid solutes can usually be dissolved. And so we can see this increasing, like for copper sulfate. At 0 degrees Celsius, only 23.1 grams of copper sulfate can be dissolved, whereas at room temperature, 32 grams can be dissolved. Whereas at the boiling temperature of water, 104 grams of copper sulfate can be dissolved. And that holds true for all of these solid substances dissolving in 100 grams of water. Okay. Now, we often read solubility on graphs, all right? So, and these are called solubility curves, right? And the curve is due to the increase of solubility, right? So it curves upwards. More can be dissolved as you increase temperature. So on a solubility graph, temperature is always on the x-axis, and solubility, the amount that's dissolved, is always on the y-axis. Okay, so going back to here again, this is when solids, we're referring just to solids. More solids can be dissolved as you increase the temperature of the solvent. Gases, on the other hand, are opposite. Okay, so again, we've got temperature on the x-axis, and we have the amount that's dissolved on the y-axis. But here we have methane gas, oxygen gas, carbon dioxide gas, and helium gas. And if you notice, it's curving downwards. Right, so as temperature increases, less gas can be dissolved in a liquid solvent. Right, and if you can remember from the Diet Coke and Mentos experiment, when we heated it up, we got a larger explosion in the hot Diet Coke. And that's because the carbon dioxide gas, right, doesn't dissolve as easily, doesn't remain dissolved as easily in the hot Diet Coke. And so it wanted to explode and get out of there faster. All right. Type of solutions. in relation to solubility. So there's three types of solutions. There's unsaturated, right, saturated, and supersaturated, right? And let's go ahead and talk about each one. Right, so in an unsaturated solution, I like to use the analogy of trains with this. Right, in an unsaturated solution, they have less solutes than can possibly be dissolved at that given temperature. Right, so think of like a train where there's only a few passengers on there and a whole lot more passengers can fit on the train. Right, that would be an unsaturated train or an unsaturated solution. It can hold more. If you hear that noise in the background, that's my little kitty and he's going crazy. All right. So a saturated solution is when the solution contains as much solute as that solution can hold at a given temperature. All right. So this would be like a train that's full of passengers. It can't hold any more. Um, and so it's just saturated. It's filled to capacity. Right now, there's one more type of solution, and that's a supersaturated solution. And that's if a solution holds more solute than it can normally hold at that given temperature. Right? And so think of a train like in India where the population is a lot greater than their infrastructure can manage. I'm sorry. Okay. Um, so they're very unstable. They're made under special conditions and they're very unstable, and the solutes will crystallize out very easily. But this is a supersaturated solution. Okay, when we make rock candy, we create a supersaturated solution. We heat up the water and pour in tons of sugar, and then we allow it to cool down. And that will cause the solutes to drop out and crystallize. Right, and so that's also how crystals are naturally formed in nature as well. Okay, so how to read these solubility curves. All right, remember that down on the x-axis is the temperature, and on the y-axis is the solubility. Okay, these lines here show you the saturation point for any substance. So any point along this line is a saturation point. It's how much of that substance can be dissolved at that temperature. All right, so for example, if we were looking at 40 degrees Celsius for this sodium chlorate, right, this one right here, this line right here, at 40 degrees, 130 grams could be dissolved, right, and that would form a saturated solution. And that's what this one just right here is telling you. All right, let's do another one then. So at 80 degrees Celsius, potassium bromide, right, this KBr right here, at 80 degrees, carrying it over, a little over 90 grams could be dissolved to form a saturated solution. So you may see a question like that, how much can be dissolved of a certain substance at a given temperature? And that way you just start at the temperature, follow it up to the line you're looking for to the substance you're looking for, and then carry it over and find how much can be dissolved. Right? Can you hear him? He's purring away. Okay. All right. Okay. So this is just talking about the saturation, the solubility, what I've already mentioned. All right. Now, uh, if a solution contains less than the amount that it can hold, remember it was unsaturated. All right. And so you're often asked, like, what type of solution would be formed if such and such amount was dissolved at such and such temperature? Is it a supersaturated solution, a saturated solution, or an unsaturated solution? Okay, so for example, here at 80 degrees, right, at 80 degrees, a solution containing potassium nitrate, KNO3. All right, so that's this one right here. Right. So at 80 degrees and 120 grams, what type of solution would that be? Well, this point right here is below that line, right? It's below it. So it is unsaturated. More could be dissolved to form a saturated solution, right? So if the point's below it, it is unsaturated. Right now, for a supersaturated solution, the point is going to be above the line. For example, here at 100 degrees Celsius, how much potassium bromide? So that's this line right here, right? And of 160. So what type of solution would be formed if 160 grams of potassium bromide was dissolved at 100 degrees? So here the point is above the line, right? And so we know it's supersaturated, okay? So it is as simple as that. Where's the point? Under the line, unsaturated. On the line, saturated. Above the line, supersaturated. Okay, now you'll also see solubility given in tables. Okay, all right, in this case, the amount given is the saturated solution. If it was less, it would be unsaturated. Right, better. It would be unsaturated. If it's more, it's supersaturated. Okay. Usually the uh, tables are more complex, and I'll show you that in a minute. But let's see here. All right. So you might be asked a question in relation to, like, we're going to look at baking soda right here. All right. So in relation to baking soda, what type of solution would it be if it was 8 grams? All right, well, 9.6 is a saturated, so 8 grams would be over here. It's hard to write. Would be over here, okay? And so that would be unsaturated. It's less than that amount, so it's unsaturated. Supersaturated would be if it's greater. So in this case, it's 11 grams, and so it's greater than 9.6, and so it's a supersaturated solution. Right, so usually the tables are more complex, might give you several different temperatures. Right, a way to make this easy is to put a U on the left, and S on the right of each temperature. Right, doesn't take but a second to do that, but it will make it a lot less confusing and take away the intimidation of reading these tables. Okay, so an example on this. What type of solution is formed when 30 grams of potassium nitrate? Okay, so we find what solution we're looking for, potassium nitrate, and it's 30 grams. All right, well, 30 grams falls in between the 13.9 and the 31.6. And so we're looking for the temperature of 20 degrees Celsius. So that's this one. So since it is less than this amount, it falls to the left. It is an unsaturated, it would form an unsaturated solution. Okay, so in this case, we're looking at 40 grams of potassium chloride. So here's potassium chloride, 40 grams, falls right around here, falls between these two numbers, and we're still looking at 20 degrees Celsius. So it is falling to the left of this 20 degrees. And so we know it's supersaturated, right? So it is as simple as that. Do this. Take this a few seconds it takes to do this just to make it less complicated for yourself. Take away the anxiety that you might feel trying to read these and just get the work done. Okay. If you're working on a computer and can't write in the letters on each side of the temperature, just make a diagram just to remind yourself. Less is unsaturated, to the right is supersaturated, and that the amount actually given is saturated. Okay, and just that's all you need to write. Just remind yourself. Look to the left or right. Take away the anxiety. Okay. All right. So for the I can statements, so I can define solubility and describe the effects temperature has on the solid solutes and gas solutes. All right. So solubility is, remember, the amount that can be dissolved of a solute in a solvent at a given temperature, right? And temperature, uh, as we heat solvents, more solid solutes can be dissolved. But for gases, as we heat the solvent, less gas solutes can be dissolved. Right? For the second I can statement, I can distinguish between saturated, unsaturated, and supersaturated solutions. Saturated solutions, the amount dissolved, a saturated solution holds as much solute as can be dissolved, normally be dissolved at that temperature. An unsaturated solution holds less solutes that can normally be dissolved at that temperature. A supersaturated solution contains more solutes that can be dissolved, normally be dissolved at that temperature. All right, I can read a solubility graph and a solubility table to determine how much of a given solute can be dissolved at a given temperature or determine the type of solution formed. So remember how to read a solubility graph. Any point along the line is a saturated solution. If the point is below the line, it's unsaturated. If it's above the line, it is supersaturated. On a table, the amount given at that temperature is a saturated amount. Any amount less than that would be unsaturated solution, and any amount more than that would be a supersaturated solution. Okay, so hopefully that helps, because that is the end.